Hi, this is Olivier Berné. I'm going to present the Labos 1.5 initiative on behalf of Tamara and myself for this A4E symposium. So what is Labos 1.5? So Labos 1.5 is a grassroots collective action to understand and reduce the environmental footprint of research. It was created in March 2019 through an op-ed in the national newspaper Le Monde in France, in which we issued a call for participation. And following this op-ed, a network of researchers and people, members of academia, joined all over France, and currently there's over 3,000 people following us and supporting this effort in France. Labos 1.5 is also a research project which was created in 2021. I will come back to that. And there is about 250 participants to this research project from various disciplines and research activities, and covering all genders, disciplines, and ages. And this research project has led to several publications that will be described also in this presentation. What are the principles of the Labos 1.5 initiative? Well, it's essentially to quantify and to understand the carbon footprint of research, and also understand what determines this carbon footprint, and also what are the heterogeneities, and that is to separate what is true from what is false on this subject. Another important aspect of the Labos 1.5 initiative is to allow the implementation locally in various places over the national territory in France, solutions which are designed and deliberated collectively, and so that we really allow the people to decide for themselves what they want to do in terms of reducing their carbon footprint. Another aspect which is important is to organize the reflective work and discuss the ethics of research in relation with the low carbon transformation of science and of our society. One of the first things we started doing in 2019 is the development of an open source tool called GES 1.5, which is an online tool that allows to measure the carbon footprint of a research lab, an institution, a university, etc. So this tool, you can access it for the French version online. It is described in this paper that has been very recently published in Environmental Research, Infrastructure and Sustainability. And basically, by inserting a number of information that you can gather, for instance, in your lab, like your electricity bills, or by sending a survey on the commutes within your research institution, you can, using the GES 1.5 tool, derive in details the carbon footprint of your institution. So this is described in much details in this paper, which is available. So I will not go to the details. What I want to insist on is that GES 1.5 is useful for people in their research labs, but it's also very useful because it allows to create a large database which collects data from all the research labs, and we concatenate all this data from various places in France to work on the contents of the different carbon footprints that we measure in France. So this is an example of what we can do with this database. There is about 100 different institutions that now have filled the GES 1.5 tool, so we have a lot of data, and each point that you see here in this plot is a different research lab, so what is shown here are box plots. So this value here gives you the median value, and then you have all the spread with all the data points. What you see here is the distribution of the emissions per capita in tons of CO2 equivalent for the various sources of emission. what you can see here is that you have a big fraction of that is due to travels, and these two different box plots are related to the fact of the emission factors we use, whether they include or not contrails, which changes the emission factor by about a factor of 2. The commutes are also a big chunk of the emissions. This is the heating, this is the electricity, and this is the cooling. Okay, so what you can see here is that basically all these sources of emission have somewhat the same level, but another important key message is that there is a very important spread if you look at the data points, and that in reality there is a lot of heterogeneity in the data, and that reasoning only on the averages is not always sufficient. In some cases, a research lab that is, for instance, located in outside of a big city, well, the commutes will represent a larger fraction, whereas a research institute that is, for instance, in the center of Paris, well, the travels can represent a much bigger chunk. Another important point is that purchasing is not included in this plot. However, we have now included purchasing in the GES 1.5 tool, and what comes out of the analysis including purchasing is that it represents a very big fraction of the emissions. In fact, the dominant fraction of the total emissions that are measured using the GES 1.5 tool. Last point is that here the research infrastructures such as the telescopes are not included, and as Jürgen, for instance, has shown, these infrastructures, in the case of astronomy, can play a very important role in the total carbon footprint. So if you get the average numbers so this is an extrapolation to the level of France for the total carbon footprint of research in France. What you get is that we have about 5 tons of CO2 equivalent per year and per person, which is already too much just for this professional footprint if you consider the Paris Agreement objectives. And the total carbon footprint of research in France is about 1 million tons overall per year, which is comparable to some countries. So it's, of course, a very massive footprint. Another thing that can be done with this kind of databases is looking at the distribution or the inequalities in terms of traveling. For instance, here what you see is the travel distance versus cumulated emission. What this plot shows here, here is the cumulative distribution, is that about the trips that are less than 750 kilometers represent only 14% of the cumulated emission. So France is a small country, but you can still travel by plane inside France, and a lot of people do that. However, the trips taken within France or at these small distances represent only a small fraction of the total carbon footprint, which is really, the carbon footprint due to traveling, which is clearly dominated by long legs, by traveling to long distances over 6,000 kilometers, I think, for the 50% cumulated emission. So this kind of analysis are important because, for instance, when we started Labo 1.5, people were asking, there were some pledges to completely forbid trips that can be done by train. Forbid the trips in plane that can be done using a train. So this may be, for symbolic reasons, a good thing to do. However, it's important to realize that in terms of the carbon footprint, this will not reduce the carbon footprint significantly. It can reduce it at most by 14% for the fraction that concerns the traveling, which is only 20% of the total carbon footprint of research in France at most. So you can have very constraining reforms, which in fact can have very little effect on the total carbon footprint. I don't have a particular opinion or something to say about whether we should or not forbid this kind of short distance trips by plane, but I think it's really important to know what we're talking about when we take these kind of decisions, and these kind of analysis are therefore useful so that we can enlighten the discussions. These discussions, according to what we think in Labo 1.5, should be taken more as much as possible locally. And so what we started a few years ago is a network of different research labs where they discuss the ways to reduce the carbon footprint of research, and using different tools, in particular financial tools like taxes, quotas, or carbon currency, or carbon offsetting. And so this network of research labs, where they're really trying to lower their carbon footprint using different tools, is a way to benchmark the different options, and this is something that is currently ongoing. And is also being observed by people from social science to see what works, what doesn't work, what creates frustration, and what doesn't, what people are happy with, etc. So it's really an experiment where we are trying to see what works and see what doesn't work. Another study that we conducted as part of the Labo 1.5 project was trying to understand also how our behaviors in research are associated to the use of fossil fuel. Something that is difficult to change is that there is a coupling between our habits, the way we do research, and how science works. And what we did in this paper is show, using the data from a national survey, that there is an association between the number of flights you take and a number of bibliometric indicators, in particular the publication rate and the H-index. So the more you fly, basically, the higher is your H-index, and the higher is your number of publication. Okay? So it means that there is a form of coupling in the success in science, at least success as measured by these metrics, which are, I think, probably considered as a norm of evaluation metrics. And it shows that it's very hard to get away from this kind of coupling. And so it also means that really the way we do our research today is strongly connected to fossil fuel in a way, and that if we want to get away from that, we have to think on how to decouple these things. And also, of course, it can be a criticism to bibliometrics, which are not necessarily a measure of the quality of science, but rather of just the productivity of science, which is something different. More details about this work. One question behind is the causality, and is it that scientists who travel more obtain more scientific visibility and get more citations? That's what we call the exposure effect, or is it instead that scientists are more visible because of their work, and then they get to travel more? They are invited to conferences, etc., because they have a higher visibility. And if you look at the data in details, what you see is that senior researchers tend to benefit from their reputations, whereas young scientists instead are looking for exposure. And that's why, in a way, you see this association in the bibliometrics and the traveling. Okay, but clearly additional studies are needed to really assess what are the connections between the practices and the carbon footprint in terms of traveling. Okay, so what can we do? That's the question behind. Well, we can change the evaluation metrics, You could think, well, we can normalize the H-index to, let's say, the number of tons of carbon that you emit. However, studies in social science, so this is the work by Jean Grasse, for instance, have shown that really bibliometrics have a lot of issues and that there are many misuses of bibliometrics. So creating a new index, like a green H index, would probably not be a very good solution. What we think in Labos 1.5 is that we need to rethink the value of scientific travel. That means when you are going to travel, you should think whether it's really necessary, if there are other ways that you can find that you don't really need to travel. And the example here is, I think many of us have experienced this, is when you go to a conference at the other side of the world, and in fact you spend a lot of time on your computer in the conference room looking at your emails or doing something else. Okay, and clearly this is not something that is acceptable in the context of climate change. And of course, something that is important is to decide collectively on some form of limitation or ethics of research, sort of code of conduct for research that should be determined. This is the kind of discussions that we have as part of the Labos 1.5 project also on how to define an environmental ethics of research. And this was, we wrote this paper that was published in the newspaper Le Monde, and this was really a call to have this discussion and to frame this discussion in the context of ethics of science, and trying to really create, include in the ethics of science this environmental impact. Okay, we also discuss, we have a seminar, which is a monthly seminar. Unfortunately, for perhaps some of you, it's in French, but everything is recorded, and we have a lot of audience, so it's very nice, and it's also a way to communicate all these very interesting ideas. Here are some lessons learned regarding the Labos 1.5 project. Okay, so really when we started, what we observed is that when you ask for permission, you really get into issues, and what we observed is that as soon as people said, oh, they asked the director of their institute, we want to do the carbon footprint of our institute, and they would say, oh no, it's complicated, we need to give you this data that is confidential, we cannot do it. What we found is that it's better just to start doing it and not asking for the permission to do it. Okay, so it's really an influence from the reclaim movements, and the feminist movements, in fact, where you don't ask the permission, you just start doing it, and that's it. And this works very well in reality. And then once you've done it, the institutions have to follow you in a way. That's very interesting. And more generally, from the beginning, also our strategy has been to avoid, imploring institutions, please do something. We know this doesn't work, and also we know that this produces what we call committeeization. That is, when you ask for something, what they will do is just say, oh, we'll create a committee to discuss these things, and this just monopolizes the energy of the people who are trying to do something. It leads to nothing. Everybody is then really annoyed, and nothing happens. So we really wanted to avoid that. Okay, so some successes related to the Labos 1.5 project. So we created an official research network and on these topics of the carbon footprint of research, and from that we got the support of CNRS and other major institutions with a funding of over 200,000 euros. So this is really, I think, a big success. Several papers coming from the Labos 1.5 project are now published, so I think it's also a success that we were able to do peer-reviewed science on this topic of the carbon footprint of research. And I want to insist on the fact that these papers are published in environmental research journals. So it's really, peer reviewed by people from the perhaps that are outside our current or usual research domains. So it was really an interdisciplinary work. Also a success, CNRS, so the biggest public institution for research in France, measured its carbon footprint using the tool that we developed, the GES 1.5 tool. And currently GES 1.5, so this tool to measure the carbon footprint of research, is being adapted in the US. For instance, Nicolas Flaget is very active at STSCI, is very active on this topic. And that's it for today. I want to thank you for your attention.